Before we continue, I've been personally funding the Finding Genius podcast for 4.5 years now, which has led to 2,700 plus interviews of clinicians, researchers, scientists, CEOs, and other amazing people who are working to advance science and improve our lives and our world. Even though this podcast gets 100,000 plus downloads a month, we need your help to reach hundreds of thousands more worldwide. Please visit findinggeniuspodcast.com and click on Support Us. We have 3 levels of membership from $10 to $49 a month, including perks such as the ability to see ahead in our interview calendar and ask questions of upcoming guests, transcripts of podcasts you're interested in, the ability to request specific topics or guests, and more. Visit findinggeniuspodcast.com and click Support Us today. Now, back to the show. Before we get started, I have a quick favor. I've been self-funding the Finding Genius podcast for 5 years now. I've done over 3,000 episodes. And as you can see on YouTube, we're up over 1 million views on the channel, which is fantastic. The next thing I really want to push on is to get up to 10,000 subscribers, because once we do, we'll be able to put a donate button, and we'll be able to solicit donations to help keep the podcast running and to also get the Finding Genius Foundation moving along. We have a big project studying anxiety, depression, and PTSD, and working on a product to help people overcome these problems, because I've seen them explode recently after the last 2 years of the whole virus situation. So if you would, please subscribe to the podcast. That would help us tremendously. Give us a thumbs up and check in the description for Buy Me a Coffee. It's about $5. If you could buy me a coffee, I'd really appreciate it. It would help keep the channel going, and I love coffee. Thank you.
Forget frequently asked questions,
common sense, common knowledge, or Google.
How about advice from a real genius? 95% of people in any profession are good enough to be qualified and licensed. 5%
go above and beyond.
They become very good at what they do, but only
0.1%
are real geniuses. Richard Jacobs has made it his life's mission to find them for you. He hunts down and interviews geniuses in every field: sleep science, cancer, stem cells, ketogenic diets, and more. Here come the geniuses. This is the Finding Genius Podcast
with Richard Jacobs.
Hello, this is Richard Jacobs with the Finding Genius Podcast. I've got a great guest today, Danny Faulkner. He was part of the Answers in Genesis and his Genesis history documentary. We're going to talk about his work in astronomy, as he's an astronomer, and we're going to talk about some of the questions he's been looking into in regards to, how Christianity and the Bible reflect what we actually see in the world and the universe. So welcome, Danny. Thanks for coming.
Oh, thanks for having me on.
If you would, tell me a bit about your background, and I don't know if you were always a person of faith or if you came to faith during your work life, but a bit about your background and how you got to where you're at now.
Well, I was born into a Christian home. Back when I was 2 years old, my family packed up stuff and moved hundreds of miles so my parents could attend Bible school. And they were there for 3 years. And then we returned generally to the area we used to live, some distance away, though. And my dad started a small church about the time I started school. And it was in that first grade that we had a vacation Bible school. And I understood for the first time that plan of salvation, the fact that I was a sinner and the fact that what that meant in terms of my eternal destiny, and the fact that Jesus had taken the penalty for me. So I was born again at age 6. I very much believe in child evangelism. You really need to reach people in their youth. And I grew up kind of comfortable in a small town. Everybody knew I was a PK, preacher's kid. And so I kind of drifted for 8 or 9 years. Everybody identified me as a PK, not as a Christian, which is, there's a difference,
What is the difference?
Oh, well, just being a preacher's kid does not make you a Christian. That's the point.
Okay, gotcha.
And so when I was in 10th grade, it turns out 10th grade was a very, very important year in my life. I didn't realize that until sometime later, but there are a number of things that took place. One of them was early that school year. I was at a public school at the time, and I found out that there were some young men, 9th and 10th graders, who were very vibrant Christians. They were letting people know they were Christian folk. And that kind of stung because people didn't really identify me as such. I was a PK. And again, there's a difference sometimes in those two. And I decided I wasn't living, not that I was being bad or anything, but living a sinful life. There's a big difference, though, in just being a good person and being a truly dedicated Christian. So I rededicated my life at that point. And, then I had always had an interest in astronomy. People ask me how I ever got into astronomy, and I can't remember a time I wasn't fascinated. While we were off at Bible school with my parents, I remember sitting on the front stoop of the house, looking up at night, probably on a summer night, and looking at the stars and being fascinated with them. And I probably wasn't even 5 years old yet. So I had a real fascination all the time growing up. I thought astronomy was really cool. And most scientists, are just into everything. If you talk to most scientists, they were into biology and dinosaurs and geology and rocks and stars and everything else. I wasn't. That was just science was just the core class in school, but we rarely touched on astronomy in that. But I enjoyed reading about astronomy and learning about it on my own. But then my sophomore year, I learned several things. Well, let me step back a second. I happened to read a book by Henry Morris. Many of your listeners will recognize that name. He was one of the co-founders of the modern creation science movement 60 years ago, and that had a very strong influence on my life. I'd read a couple of books prior to that had suggested things like day, age, and such, and I thought, well, that isn't what I've really learned at home in a church, but these are Christian men, dedicated men, and so they know more than me. So therefore, perhaps they're right about this. But when I read Henry Morris's book, first one I read, I realized immediately that he was offering something very different, something that was thousands, not billions of years old. And it squared much better with scripture than the others. So it kind of pulled me back from the brink. I was heading down the wrong direction a little bit there, but that kind of reconfirmed me in that. And about the same time, again, my sophomore year of high school, I discovered that people actually made a living being an astronomer. And I thought, well, that's pretty cool. Just some guys dream of being baseball players and football players. Why not dream of being an astronomer? I can still do it in my 60s. There aren't too many baseball players in their 60s. So I decided about that time, I also learned that I had the ability to do this. And then I also learned that I believe that was my calling in life, to be an astronomer for God's glory. And that became my direction of goal, my life. And prior to that, I had never given any thought to what I would do with my life. I was too busy being a kid. So at the age of about 15, I decided that was my direction. So I began preparing myself. I went off to college at Bob Jones University, a Christian university, where I met up with some professors there who were very much dedicated to creation, biblical creation, and that really helped ground me. And then I went off to grad school. I was in the physics department at Clemson University in the late 70s, finished a master's there working on an astronomy issue dealing with eclipsing binary stars. And then I went to Indiana, where I finished up a master's and PhD in astronomy. My dissertation was actually on the atmospheres of cool giant stars, but I've always kind of come back to eclipsing binary stars because it's the kind of science one can do without huge telescopes. You can use kind of the minimum size research telescopes, and you don't need a huge department with all sorts of people and funding to do it. It's really ideal for people who are at smaller institutions, and I always imagine myself there. So as I was finishing up my studies, I didn't quite finish yet, but I did finish a little later. I took a job as professor at the University of South Carolina, Lancaster. It's a regional campus of the USC system. It's in the north central part of South Carolina, not too far from Charlotte, across the state line in North Carolina. And had no idea how long I would be there, what I would do, but it really was a great environment for me. I blossomed there. I did very well. I was a full professor. I was tenured. And keep in mind that this is a state university campus. And I was didn't take long to be outed as a recent creationist, and it really didn't matter. I'm really proud of the University of South Carolina. They treated me very well, and there are a few times that people from outside the university tried to get me in trouble by pointing out, hey, you've got a recent creationist on your faculty, and they said, so what? It's academic freedom. Leave us alone. So
especially today, that's unusual. Yeah, it's good.
Well, and not every story is like the one you find in the movie Expelled. It really is. Depends on the situation I was in and how I conducted myself too. So,
quick question, a couple of questions here.
Yeah.
Okay. What is, let's say, one thing that astronomy has confirmed for you that yes, the Bible's real, creation is real, etc. And then after that, I want to ask you, what's at least one thing that's a great mystery that just, there's no answer to yet. You're not sure how to solve it, but it's a very important issue that also either supports or doesn't support creation.
Well, I see evidence of planning and design in the universe. I wrestle with the idea of design, exactly how to define it. It's one of those things that you maybe can't define, but you can recognize it when you see it. And I see, for instance, for the Earth as a planet, it has some very interesting properties that, well, if the Earth were any different, we wouldn't be here probably. We orbit an unusually stable star for its type. Stars like the sun tend to be unstable, which means they vary in brightness by several percent. And I think with all the hand-wringing over climate change I think most people recognize a 2 or 3% change in the sun's brightness would be catastrophic. Well, the sun doesn't do that like most of its similar type stars. The Earth is orbiting at a really a proper distance from the sun, closer or farther away. Appreciably, it would be problematic. Mars and Venus are good examples of what can go wrong.
Yeah, one thing before you go on, can you give the tolerances as you go? So you said the sun's intensity doesn't vary by 2 or 3% like other stars do. How much does it vary, and what, like ballpark? And then as you go through the other factors, again, what's the the error bars on it?
Yeah,
Where we wouldn't be here if it was out of whack.
Yeah, it turns out the variability of the sun has been barely detected, and it's like less than 0.1%, and it's not much at all. It's not even that great. It's really, really tiny. So one part in 1,000 is too high. Probably closer to 1 part in 10,000 would be more like its variation. Which when I say I should qualify it as stars like the sun, they've been looking for years for what we call solar analogs, stars that are like the sun, and they usually look for stars similar mass and temperature and such. But most of them, it took them years to find another stable one. The stars like the sun tend to vary over just a small amount, a percent or so, but that would be catastrophic. Stars as stable as the sun, apparently, in that class of stars is pretty rare, as it turns out. As far as distance is concerned, they define what's called a habitable zone around a star, and the Earth is pretty close to that habitable zone. Exactly how much bigger than the Earth's orbit is a little bit of a dispute. But, if you change the Earth's orbit by maybe 1 million miles or so, 1% of its distance from the sun, it would make it a little warmer, a little cooler, but it would not be catastrophic. I think if you change it by 10%, you're probably heading for trouble. The Earth's atmosphere is unique as far as we can tell. It's a diatomic nitrogen base, which means the 78% of our atmosphere is nitrogen, and it's in molecular N2, which means two atoms of nitrogen bonded together to form one molecule of nitrogen. And much of the rest, 21%, is diatomic oxygen, two oxygen atoms bonded together to make one oxygen molecule. And so far more than 99% of the Earth's atmosphere is made of this diatomic substance. And that's interesting because most atmospheres of planets are made of polyatomics. These are atoms that have 3 or more atoms per molecule, and they're greenhouse gases. And people, again, with climate change, they're really concerned, wringing their hands over polyatomics, particularly CO2 in the Earth's atmosphere. And I used to ask my students, I still ask when I present on this, is the greenhouse effect good or bad? And the correct answer is yes and no. It's you need some greenhouse gases to keep the planet reasonably warm at night. If we didn't have any greenhouse gases, even on hot summer days, the temperature at night would plunge well below freezing. And people don't know that. That's the reason why in desert environments, it can get very hot in the daytime, but it can also get very cold at night. It swings back and forth. Where I live, it tends to be kind of humid, and so we don't lose that much heat at night. Water vapor is a very important greenhouse gas. So we've got this delicate balance of just enough polyatomics, but not too much to make it bad. Like Venus's atmosphere is unbelievably bad. It's very thick, and it's almost entirely CO2. And that leads to a temperature of about 900 degrees Fahrenheit day and night on the surface. It's actually hotter on the surface of Venus than it is on Mercury, even though Mercury is closer to the sun.
Oh, wow.
So the atmosphere is unique, and so much so that when they're looking for exoplanets that they think could be like the Earth, they're getting to the point maybe with the James Webb Space Telescope to start looking for atmospheres in some detail on exoplanets.
Oh, one quick question that comes to mind.
Yeah.
So the side of the Earth that's facing the sun, how much more solar energy is it getting versus the opposite side that's not facing the sun? And without our particular atmosphere, what would be the temperature delta? Let's say like on the moon or on Mercury, how much does the atmosphere contribute to keeping that temperature delta to still a livable range?
Oh, yeah, the daytime side of the moon. Now, keep in mind the moon takes a day on a moon is about a month because it rotates and revolves around the Earth at the same rate. But the temperature variation is on the order of about 400 degrees Fahrenheit. It goes from well over 200 degrees Fahrenheit in the daytime to something like 200 degrees Fahrenheit below zero at night on the moon. That's the surface temperature. So from day to night, if you didn't have an atmosphere at all, it would be probably 400 degrees, 300 or 400 degrees easily on the part of the Earth. But the atmosphere, a little bit of polyatomic makes all the difference in the world. If you'd had no polyatomics, you'd be in deep trouble. We'd have killing frost every night. and that would be unbelievably bad for life.
Yeah, interesting.
And then
So the delta on our planet's about 400 degrees without atmosphere is what it's calculated.
Yep. So it'll be I'd say between 200 and 400 degrees. I mean, it's something I'm not really noodled around in, but it's something that's not that difficult to do. But it would, again, the temperature would be higher in the daytime because the polyatomics also block out incoming sunlight. That's another reason why a place like Phoenix gets so hot in the daytime. There's a lot of infrared radiation that comes in during the day. People don't realize that CO2 and other polyatomic gases, it's a two-way wind blockage. It keeps it from going out at night, but it also prevents it from coming in the daytime in the first place. So I've lived in places that are similar latitude to Phoenix, but they don't get nearly as hot in the daytime. A temperature of 105 is pretty rare in those places, but temperature of 105 in the summer is pretty cool, actually, for Phoenix, even before the recent heat wave they've had. But then again, it gets a lot cooler at night out in the deserts of Arizona than it would other places. So the atmosphere of the Earth is one of those unappreciated things. But I was going to say that with the James Webb Space Telescope, when they're looking for Earth-like planets, they want to look for an atmosphere that is dominated by diatomic nitrogen. And where did they get that idea? Well, because that seems to be the perfect atmosphere, and they learned that by looking at the Earth. So that's impressive to me. We have a tilt on the Earth axis that produces the seasons, that 23.4 degree tilt. And another little fact that I didn't know until about 20 years ago, I guess, perturbing effects of objects in the solar system act on the rotation axis so that over time, it would take a while to do this, but over time, the rotation axis tilt would go from what it is today to 90 degrees back to zero, and in which case you would have wildly fluctuating seasons and no seasons at all sometimes, which I think would be less than ideal. If the tilt were close to 90 degrees, then much of the Earth would simultaneously be in the tropics and in the Arctic or Antarctic, which is bizarre, but that would be the case. However, it doesn't happen because we have a moon orbiting the Earth, but not just any old moon. The moon has to have a certain amount of mass. It turns out the mass of the moon is fairly high compared to the Earth. The Earth is only 81 times more massive than the moon. Now, that may sound like a lot, 81 to 1, but for all the other orbiting bodies around planets, what we call satellites of the planets or moons, the ratio tends to be thousands, tens of thousands, hundreds of thousands, or even millions to 1. So when you look at the big picture, the moon and the Earth are very similar in mass to one another, and so much so you could even call the Earth-Moon system a double planet. But the other thing is the orbit of the moon around the Earth is unique. It orbits in the ecliptic plane. That is the same plane that we orbit the sun, and no other natural satellite in the solar system does that. Only our moon does. And when you realize that, it's interesting because of that unique feature of the moon's orbit and its relatively large size, it stabilizes the Earth's rotation axis to a range of about 2 degrees. And that's fascinating because this is the only planet we know of this happens. And it's the only planet where it's really important for living things. And I often, when I talk about this, I ask people, well, that could be a coincidence, but how many coincidences are you allowed to have before you begin to realize that these aren't coincidences? And,
that's what I was going to ask you is, have you ever seen or could you generate a list of all the known factors that allow us to live and then the probability of each and the final probability that we're here?
Well, that's been done, actually. There was a Christian fellow named Guillermo Gonzalez who back 20 years ago, at least, wrote a book called Privileged Planet. And there was a DVD movie made out of it as well. And he went through this, and he's a bit of an expert. I think his dissertation was on habitable zones of possible planets outside the solar system. And when he did this, now, I would disagree with him on the age of the Earth, but he is a creationist. I mean, he believes in creation, he just believes in millions of years. But he made up in that book, he made a rather long list of things of how perfect they have to be for life to exist. And about the same time, there were 2 other astronomers who are not Christians, as far as I know, who wrote a book called Rare Earth, where they reached much of the same conclusion. Now, the first book was about design. The other was about how lucky the Earth is like this and how rare we are in the universe. It tells you a lot about worldview differences between people. So this has been done. Hugh Ross talks about this quite a bit. Again, I would disagree with Hugh. He's a friend of mine, but we disagree on the age of the Earth, but we do agree on certain things about the design aspects of the Earth. But, back in the 90s, it's been now over 25 years ago, almost 30 years ago now, they began detecting exoplanets for the first time, planets orbiting other stars. And the technology's come a long way since then. And many people don't realize that how many exoplanets are now known. We passed the 5,000 mark last year, and we're closing in on 6,000. Now, if you would have gone back 30 years ago and asked the average scientist or maybe an astronomer, when we found 5,000 exoplanets, how many of those would be Earth-like? And I think most of them would have said, oh, probably hundreds. Well, guess what? There aren't any Earth-like exoplanets. Out of 5,000 plus almost 6,000 exoplanets, none of them appear capable of sustaining life. There are few of them that they hope and wish, but there's some real problems if you look into it. So I'm of the opinion there aren't any. So when you look at 5,000 or 6,000 exoplanets, none of which come close to the standard that the Earth has for life, you begin to get the impression the science is telling you that life is probably unique to the Earth. And that's a powerful message.
Do you remember again the percentage likely, or sorry, the theoretical probability that the aggregate probability that Guillermo Gonzalez figured out that we're
I
here?
I don't remember off the top of my head, but it's extremely remotely. I mean, it's on the order of millions to one, probably.
Okay, but it may be like into the 40th to one or something, some crazy number. But yeah,
no, it's not like that. It's
small.
Even 100 to one or 1,000 to one would be optimistic. And the fact that we have 5,000 plus exoplanets is indicative of that. If it were like 100 to one, we would have found on average 50 Earth-like planets. So far, we haven't.
Okay. So what are a couple of factors that to you can't reconcile them with creation? For instance, the light from faraway stars and the redshift.
Yeah, that would be
being so big.
That's exactly where I would go. I recognize that as a conundrum over 50 years ago when I was just starting out in all of this. And we call this the light travel time problem. And over the years, there have been several suggestions put forth. I put my own forth about 10 years ago about how we could explain the distant starlight. I think it was a miracle of creation. The whole creation week was a miraculous thing. And if you would have gone into the Garden of Eden on day 7 or day 8, and you would have examined the plants there and the animals and Adam and Eve, you would have said, well, man, the creation's been around for quite a while because it takes a long time for these things to develop. And you'd be completely wrong because they're not even a week old at that point. And so that's because you're not accounting for the miracle of creation. So that's my opinion, that there was a miracle that took place. And I've written about this quite a bit and given more detail on it. But I would say right up front, that is the most obvious difficulty we have. Not insurmountable, but it is a problem for us to deal with. And in astronomy, that's the number one and has been for over a half century, in my estimation.
Well, is there any resolution? Like, why? What does it tell you that again these stars are so distant? The light is takes so long to get here. Like, what's the reconciliation of that?
Well, my reconciliation is that God created a miracle on day 1 when day 4 when He made the stars. I kind of made a comparison to day 3 creation. God said in verse 10, I think, or was it 11? He says that let the earth bring forth all of these plants. And the next verse says, and they brought forth all these plants. And for the longest time, I assumed the same word was being used, the same verb, bring forth and brought forth in the King James. As it turns out, they're actually two different verbs, two different words entirely unrelated. They both have overlapping meaning, and they can mean to bring forth, produce, thrust, shoot. And when I realized that about 20 years ago, I looked at it and I thought, wait a minute, these are very dynamic terms. If I would have been in the garden at the time of creation on day 3 and would have seen this, what would I have seen? And what it came to me was from the dynamic language given there, you had all these plants ripping up out of the ground very rapidly, much like a time-lapse movie would be, except it would be real time rather than time lapse. So what you would see is plants ripping up out of the ground, trees going up, branches, twigs, catkins, flowers, fruit, leaves, all in the course of a day. Normally what might take 50 years for a tree to develop. And there's a good reason for this because within a few days you'd have plants and animals and humans that would be eating the fruit of these plants of various types. And if you would have waited for them to grow naturally, they all would have starved to death because it takes a couple of months minimum for even the fastest growing garden plants to do that. So a miracle was brought forth. And it's interesting, the year that as Genesis History movie came out. There's another movie, Genesis Paradise Lost, that Eric Hovind put together. By the way, I had the distinction, someone pointed out to me later, I'm the only person that appeared in both of those movies the same year. It was interesting. And I love the way Eric depicted the day 3 creations. Plants were ripping up out of the ground exactly as I had envisioned it. So if God used a very rapid process on day 3, as indicated very clearly, to grow the plants, not just poof and create the plants immediately, but to grow them up out of the ground, why could not have God have brought forth that light from every distant corner of the universe to the earth in a miraculous way on day 4? And, I think a lot of my creation science brethren, the physicists among us, want to argue the physical mechanisms dealing with general relativity and so forth. But I asked them, well, is there anything else in the creation week that you would explain by natural or physical means? And the obvious answer is no. So why do you require a natural physical explanation for something going on in the creation week that we don't quite understand? We don't understand how life can come from non-life, how God could create man from the dust of the ground and Eve from the side, but we understand that's what happened. So why is it difficult for us to see that God miraculously brought this light to us on day 4? Now, that's not going to satisfy the naturalist, the person who's going to rule out a deity to begin with, or a person who's committed to physical or natural explanations only, but they're going to reject creation anyway. I found that most Christians and creationists like my explanation because it's consistent with how they understand creation to be anyway.
Well, I guess some people have said that maybe the speed of light was, a lot greater years and years and years ago. Like, what are some possible answers to this that I'm sure you've thought about it over the years?
Well, I mean, essentially what I'm doing is I'm arguing that. I'm saying the speed of light was virtually infinite on day 4. The difference is I'm not saying that this was done in a material or physical way. The arguments about this changing speed of light have all come down to some sort of physical change in the constants of nature that allowed this to happen in a naturalistic sort of way. And I don't think the Lord has to work that way. He's the creator of physics. He's the creator of how the way the world works. So why should he be bound by the rules that he put in place? During the creation week, I don't think that physics as we know it quite existed. I think maybe bits and pieces that came into existence, but it really didn't fully start functioning as the way we understand it until the end of day 6. So I'm not looking for a physical mechanism that make that happen. I think that's what these arguments with general relativity and changing speed of light are all about. They're looking for that physical mechanism. And I'm saying, well, why don't you just look for a physical mechanism for the virgin birth of the resurrection? They're all miracles.
Okay. I mean, still, I would think it would gnaw at you and you'd want to figure it out, over years and years and years. Like,
it does.
Like
it does gnaw at me. It really does. I think, I would like to flesh this in. I put this proposal out officially a decade ago. And what I'd like to do is kind of work out the details. Like, for instance, we go from the miracle of creation to the day by day stasis, the upholding of the creation, as Colossians 1:15 and 16 and Hebrews 1:2 and 3 talks about. And I've not yet got a handle on how that might take place, how we might go from the miraculous to the stasis of today. And that's the question people have posed to me. It's a question I posed to myself, and I've not resolved that. So that's the reason why I would put this at the top of the list of problems that I have. I have a solution. It's not a complete solution. I'm not 100% satisfied with it, but it is my best guess as to what's going on. So yeah, it still gnaws at me, as you said.
Okay. What other events? I mean, like, I don't know if you deal with quantum mechanics very much, but, let's say black holes or, supernovas or other, super large cosmological, entities. Any difficulties or supports of creation? Or, let's go back to the other side of the ledger, I guess. Like, what are some things that occur in our universe that support creation, that show, that it was orchestrated, it was planned, it was designed?
Well, I think the physical constants of the universe are that way. Other people have made this case before me that the idea is that today is that the Big Bang occurred 13.8 billion years ago, and it happened in a random manner so that you generate the physical constants of the universe. But the universe is somewhat improbable. There was a guy named in 1972 or 73, Brandon Carter coined a term called the anthropic principle. And what he meant by that was, and this has been discussed much up to that point and continues to be, that the universe has certain characteristics about it that make life improbable. If you change the charge, the attraction of the electron and proton slightly, it would change everything, chemical structure and the whole bit. If you change the nuclear constants, things would not work very well. And so you look around and the universe appears designed, is what he was saying. And this is something that needs to be explained. And in the 1980s, late 80s, Barrow and Tipler wrote a book called The Anthropic Principle. And it's a tome about 1,000 pages long. It's a very complete treatment of the history of and different forms of the anthropic principle. But when they get done with the book, basically what they conclude is that the universe appears to be designed, and it's only an appearance of design, nothing more. And I find that just remarkable. It shows extreme bias that they had. They've got design staring them in the face, and they just throw it away. But in the last 20 years or so, 25 years, there's been an increasing interest in what we call the multiverse. The idea that there's an infinite number of universes and maybe new universes are spawning all the time. And one of the motivations, I think one of the prime motivations for this is that if universes are generated all the time, there's an infinite number of them, each one of them generated randomly, then it would seem that only a tiny, tiny fraction, a very small minority of universes would be hospitable to life. And so we just happen to live in one of the few universes that is actually hospitable to life. And we shouldn't be surprised by that fact, because if we were in any other universe, we wouldn't be here because life would be impossible. So the selection effects, life can only arise in universes where life is possible. And so it's stacking the deck. It's a recognition, I think, tacit though it may be, that this universe is highly improbable, i.e. there's design. So to avoid design, you simply appeal to the infinity and play the odds. You play the probabilities by increasing the number of chances you have it. And that, I think, is a very strong indication that even secular, even atheistic astronomers and cosmologists realize they have a problem, because this universe is designed.
I mean, the multiverse concept, is there like one shred of evidence for it, since you're
No.
Essentially in the field?
Not bit. And how could it be? I mean, really, if there are other universes and we understand what the universe is, the totality of physical existence, then if there's another universe, by definition, it can't really interact with our universe now, can it? And in fact, if it did, then, well, that means that it's part of our universe now. So it's kind of, self-contradictory there. This idea never can emerge into the realm of science. It will always be philosophical, theological, or just science fiction, but it's hardly science. Just because a scientist talks about some topic, it doesn't make it science. They can muse all they want about this and even put a lot of physics behind it, but it's still just a speculation and conjecture. I often make the comparison to the late Stephen Jay Gould. He was a big fan of baseball, and he wrote about baseball quite a bit. But just because he's a scientist and he wrote about baseball, it doesn't make baseball science any more than talking about the multiverse makes it science.
Okay. Any other, I guess, features in the universe that just, I don't know, you can't even get your head around, that just amaze you? What about like dark matter or black holes? I mean, how do they? I
was going to bring up dark matter. Dark matter is a fascinating thing. I'm very bullish on dark matter. The evidence goes back to. Yeah, I'm very bullish about it. It goes back to almost 90 years ago now, the first evidence for it. And, astronomers kind of ignored it for 40 years or more. And it was in the 70s. By 1980, astronomers finally reluctantly said, okay, there is dark matter. It took cosmologists another decade or two to embrace it. It's such a weird thing, but there's abundant evidence of the thing. And I've written about this a bit in creation literature, because unfortunately, a lot of my creation brethren, they don't like dark matter. They're very suspicious of it. But I'm saying, hey, this is really cool, because the Lord made the universe so that 90% of the mass of the universe is not visible to us. And it's a form of matter we've never contemplated before. We have no idea what it is. Instead of looking at that and thinking, well, it just can't be, I'm looking at it and saying, wow, this is fantastic. God made this universe far stranger and weirder and wonderful than anybody could have ever imagined. And it's our job, our duty, I think, as creation scientists, to try to figure this out. That's an example of those really wow moments, and that there are a lot of mysteries still hidden that the Lord has not revealed to us. We have to kind of figure that out on our own. And to me, that's a very important calling in life. It's a very Christ-honoring thing for us to study these things. So I like dark matter a lot. I think black holes are really cool, but there are a lot of mysteries in astronomy yet, and that to me, that points back to a creator as well.
Okay. So do you think dark matter is a real thing, and why are we not able to see it, or why does it not seem to interact with anything in our universe?
Well, it does interact gravitationally. It's the only way that interacts is by gravity, and that's how we detect it. There are three major lines of evidence for dark matter. The first was in the orbital motion of galaxies and clusters of galaxies, and then there was the rotation curves of spiral galaxies, particularly, that showed that there's a lot of unseen matter unaccounted for here. An interesting thing is it kind of avoids where the lighted matter is. The lighted matter is kind of concentrated at the middle of galaxies, and the dark matter is kind of concentrated in the perimeter of the outer parts, what we call the halos of the galaxies. So there's kind of an anti-correlation there. So, and the third evidence is coming from gravitational lensing of distant object by clusters of galaxies. And each one of these are virtually independent of one another, and each one of them comes in at kind of an average of about 10 times the amount of dark matter over lighted matter. When you have three independent lines of evidence all telling you the same thing, and even quantitatively telling you the same thing, you really ought to stand up and listen. That's three witnesses, and that's a biblical standard, 2 or 3 witnesses. So there's something funny going on in the universe, and I think that's fascinating.
Yeah, no, that's really interesting. Do you think that there's questions and things that we're just never going to know because, God won't allow it? It'll be like, all right, that's enough, and keep you back from this. I guess when I look at physics, it seems like, like a nightclub that have those velvet ropes that won't let you into certain areas unless you go through security. You know what I mean, right?
Yeah, possibly. But, we've been tearing down the barriers to our understanding for a long time. 400 years ago, we had the modern revolution in science and physics as we know it began. And they developed this idea Newtonian physics was all there was and just had to work out the details. And at the end of the 19th century, there was just a host of experimental results that didn't make any sense. So in the early 20th century, we saw the development of quantum mechanics and general relativity, which are considered the two fundamental pillars of modern physics. And they are very successful theories, but the two are incompatible. There is no theory of establishment of quantum gravity. And in fact, they view quantum mechanics and general relativity view gravity in a very different way, and they are incompatible. And that tells us that the theories are incomplete. It's believed, and I think it's probably true, that there's some better theory beyond those which would tend to unify them together. And we've seen this gradual unification of physics. But just when we begin to think, I should say, that we've arrived and we've understood everything and we know about everything in the universe, we get mugged by reality. And we find out there's a lot we didn't know. And I just think it's like an onion skin. We've gone through a couple of layers of the onion, but there's a lot more layers down there. So I don't know if it's so much that the Lord is, saying you can't go here. It's just that he's made it quite an enigma, quite a puzzle for us. And I think it's, again, pleasing to him that we can, as creatures that he has made and made us curious, I think it's God honoring that we can do this and investigate these things. Science should be something that Christians are really bullish about and really wild about, enthusiastic about. And, here at the Creation Museum at Answers in Genesis, we are like that. We love science. We get accused of being anti-science, but nothing could be further from the truth. We love science. So we want to peel back some more layers of that onion the Lord's presented us with.
Well, what I mean by velvet ropes is like, we'll never, it seems like it's absolute zero. It's impossible.
Yep.
You have the Heisenberg uncertainty principle, which by definition doesn't allow a lot of things. We'll never get to the speed of light. It seems like we'll never be able to visit 99.99999% of the universe. It just seems like, again, there's these velvet ropes that I don't think we'll ever get beyond.
Well, you may be right. But, people in the past have thought we've been limited. I was just reading it earlier today about some cults in the 18th and 19th century, and they never envisioned that we would one day be able to travel to other planets. And so they or even discover other planets. And so their vision was very, very dated and very limited. They claimed to have this, be able to travel, kind of virtual travel or something, be whisked to these planets. And one in particular, I was just reading about this morning, it was able to visit all the planets in the solar system, except they didn't mention Uranus or Neptune, or for that matter, Pluto, because they haven't been discovered yet. And if they were such a great prophet or prophetess and understood these things and were really going places, wouldn't they have been able to predict these for everybody? So I think my point is that we tend to be limited in our understanding. We tend to think today, well, the uncertainty principle prohibits us from going beyond that. But that's a result of quantum mechanics, which everybody agrees is an incomplete theory. If one day we replace quantum mechanics with something, maybe it will pull back that veil, that layer of the onion. Turns out we can actually then actually determine things that the uncertainty principle said that you couldn't. So I don't know where to draw the line, where God says, okay, you can't go past this level of the onion, or he puts up a velvet rope in your analogy. So far, the limitations have been just based on our understanding, not something we're prohibited from doing. So I don't know. I tend to be more optimistic than you are, I guess, about it.
Yeah, I'm not trying to be pessimistic about it, but I just wonder again if there's just things that we're just never going to get there on. We won't be able to get there. The universe has been, by God, has been fundamentally designed in such a way, like we're kind of stuck inside the playpen. We don't want to. He doesn't want us to fall out and hit our head.
Well, it could be that we have just started to work on the surface of the onion. There are many, many layers below. And while he's not prohibiting us from going there, there's not going to be enough time. I don't think humanity is going to be here forever. There's going to be a new heaven and a new earth. And, learning more about him and maybe more about his creation is something the attorney's for.
Well, how do you feel about your astronomy work? Do you feel like you're understanding the nature of God and why he created and how he created as you learn? Or like what is it felt like to you, and what has it satisfied in you to learn the things you're learning?
Oh, it's been very satisfying, very pleasing. I'm getting up in years, and I'm looking back a lot now on my career rather than looking forward. And I've had some things I wanted to look into that I just haven't been, like fully understanding the light travel time issue. I got a sense that there will be people after me that perhaps will see beyond where I've done and hopefully use some of the meager steps that I've taken. But I have the confidence that I'm doing exactly what I was made to do. As I said, as a sophomore in high school, over a half century ago, I decided my calling in life was to be an astronomer, and I've never wavered from that. And as I said, I think I'm doing just what the Lord made me to do. And I find that very satisfying that I'm doing what he wants me to do.
Okay. Well, excellent. Any other questions that you're pondering that, something that you feel will be really important to understand, but it's going to take quite a bit of work to understand it? Any other main questions that that are on your mind?
Oh, we've touched a lot. I would love to know what dark matter is. Sometimes people ask me, what is dark matter? And I tell them if I knew the answer to that question, I'd have a Nobel Prize in physics. It's that big of an issue. I would love to know more about the structure of the universe. I'm not an expert on quantum or general relativity. I know somewhat about it, and I have friends that know more about it, and I love discussing with them. But I would love to know more about the workings of this universe. It's amazing how deep that is. So literally in astronomy, the sky's the limit, but pardon the pun, but there is so much about the universe we do not know about or we don't understand completely.
Yeah, no, true.
And it's quite a challenge, and yet it's a healthy and it's a wonderful challenge that I look at it with a lot of enthusiasm and a lot of joy, because we live in a wonderful world that's been created by a wonderful creator for our benefit. And I think the study of the world is part of the dominion mandate, going back to the Garden of Eden. That little bit of something godlike in us. We're created in his image and in his likeness, and that has to do with our will, it has to do with our intelligence, our social nature. And I think it's natural that we would be curious about the world and want to learn more about it. And the best way we have of doing that is through science, which I keep coming back to this, I think is originally was and still can be a God-honoring profession and goal.
Okay. Well, very good. Well, Danny, thanks so much for coming on the podcast. What's the best way for people to see the things that you're looking at and working on?
Well, they can go to the Answers in Genesis website. It's real difficult to remember. It's just simply answersingenesis.org. That's all one word, answersingenesis.org. I have no idea how many articles out there, probably 100 at least. I write more technical articles in the Answers Research Journal there. I just completed recently a series of 5 papers there on philosophy of science, which I've been stewing on for several years. But I continue to write in-depth articles. We have Answers in Depth. I have shorter articles we post. Plus, I have a blog there as well. And I've got a series of 3 blogs coming up on our website dealing with eclipses. There's the April 8th, 2024 eclipse. We're just now, 6 months away from that eclipse, 7 months away. And
where's it going to be?
It's come out of Texas, totality across part of Arkansas, part of Illinois, and across Indiana, Ohio. It just misses us here. I'm going to drive up near Muncie, Indiana. That's my plan right now to see it. I try to get to center of line so I can get 4 minutes of totality. I've seen 2 total solar eclipses before, and I will have a total of 4 minutes and 45 seconds in totality. So I'm going to nearly double that if the weather is clear. But I tell you what, totality is the most incredible thing I have ever experienced. I mean, I didn't understand it until I saw one. And then I got it, and no picture, no description can do it justice. I tell people, if you ever see one, then you'll know. You understand, okay, I know what you're talking about, what you're raving about. It's the most remarkable thing in all of creation. And here's a design aspect for you as well. This is not essential for our life, but just having the bare essentials is not much of a life. It's nice to have a few flowers along the way. And total solar eclipses are part of that. The sun is 400 times larger than the moon. Yet the sun is 400 times farther away, which means that the sun and the moon appear about the same size in the sky, about a half degree, which isn't big. And so during a solar eclipse, the moon barely covers the sun. And that results in extremely spectacular and extremely rare total solar eclipses. I read once many years ago that on average, any given location on the Earth is about 4 centuries between total solar eclipses. It can be more than that, it can be less than that, but that's the average. So if you're going to see one, you really have to be lucky or plan to travel to see the thing. And there's no other planet in the solar system that experiences the combination of rareness and the spectacular nature of solar eclipses. And that tells me, first of all, that God is an artist. And it also tells me that he's an engineer because he designed it just for us, I do believe, here on this planet. And so I got a series of 3 articles dealing with eclipses. There's an annular eclipse coming up in October of 2023 that I plan to go to Albuquerque for, but it's not nearly spectacular but as a total solar eclipse. But I've got 3 blog articles coming up soon on eclipses in general. So I continue to write about all sorts of things that interest me, dealing with news stories in astronomy and in physics, and dealing with interesting events going on in the sky, such as eclipses and so forth. So I would suggest, again, the website. I also have several books that are out, I think 7 books now and a couple of pocket guides. My most recent book came out less than 2 years ago. It's called The Heavens, a Different View, and it's a picture book. It's a coffee table book. It's got astrophotos that I and 2 other people have taken, 2 amateur astronomers who are actually better at this than I am, but we got pictures in there, and I wrote the essays for it. And it's a beautiful book, fantastic Christmas gift, by the way, for people. And that's been out for 2 years. I guess my most recent book, though, came out this summer. It's a high school astronomy textbook. It's a 1-year course meant for maybe 11th and 12th grade. It's called Intro to Astrophysics. And that's available through us, and also Master Books, who's the publisher. Those are my 2 most recent books. And if you want to get a sense of what I'm all about in astronomy, you might want to get that book and read through that book, because it's kind of the most complete treatment of creation astronomy as I see it in one place. I've done it in a couple other places too, but that's my most recent, and I think probably the most readable one.
Okay. Well, excellent. Well, Danny, thanks again for coming on this podcast and taking your.
Well, it's been my pleasure to be here. Thanks for having me.
If you like this podcast, please click the link in the description to subscribe and review us on iTunes.
You've been listening to the Finding Genius podcast with Richard Jacobs. If you like what you hear, be sure to review and subscribe to the Finding Genius podcast on iTunes or wherever you listen to podcasts. And want to be smarter than everybody else? Become a premium member at findinggeniuspodcast.com. This podcast is for information only. No advice of any kind is being given. Any action you take or don't take as a result of listening is your sole responsibility. Consult professionals when advice is needed.